The first part of the code was to initialize everything, and then it goes to the function called comparison that is in the for loop. In this function, the first part is to determine the mode of the AGV, that is determined with the variable modo autónomo. When it is equal to 1, the LP is initialized and goes to the function modo autónomo. If it is equal to 2, it deactivates the LP, determines a specific duty cycle, and goes to the function manual. You can go into this function by sending an A as the first letter of the command. In this function, the duty cycle is determined at the first part, and then each time that the AGV detects a color red, the code runs the first letter you send after the A. You can send an F for front, R for right, L for left, U for raise the mechanism, and D to lower the mechanism. An S is always added at the end of the command. After each action it runs, function called seguidor de línea. After each action, the code will run an action called seguidor de línea. In the function seguidor de línea, the robot is following the black line by stopping one motor or another to maintain it inside the black line. By using infrared sensors, when the robot detects another color red, it returns to the function modo autónomo. In the function seguidor de línea, the robot is following the black line by stopping one motor or another to maintain it in the black line. By using infrared sensors, when the two central infrared sensors are reading the black line, both motors are moving forward. You can go into the function manual by pressing any button of the app in the manual mode. You can move the AGV front, back, to the left, to the right, or moving the mechanism up or down. Every time you drop the button, an S is sent to the robot.
This is our main screen for our application. And once we open the main screen, we go directly to the manual control. Every time we click one of these buttons, the command is sent via Wi-Fi. Here at the bottom we can see what has been sent. This is our IP address of the Wi-Fi module. And we have an emergency stop button here. And if we want to send a set of instructions for the semi-autonomous mode, we just click here on set app, and the command is going to receive all of our instructions one after the other. It's going to concatenate them. So once we are ready, we click send, and here we can see at the bottom what has been sent. It adds automatically the letter A for autonomous, and at the end it adds the letter S for stop. And if we want to go back to the manual control, we just deactivate this button and we can go directly to the manual control. Here at the bottom we can see what has been sent every time we make a click, and when we click it sends a letter M for manual and then the R for right, and once we stop clicking it sends directly an S just for security. And here we can go to the monitor part. First we have to connect Bluetooth, and the Bluetooth module is going to be sending us constantly the values for these variables. We can go back to the console of the AGV. Here we can set up the IP address of the AGV, so we can control more than one AGV set with the same application.
Also, as part of the project, we had to design a mechanism that is capable of lifting an 8 kilograms load. And well, on the video, we can see how our robot is able to lift an 11 kilograms load. One of the project requirements is that the AGV has to climb a slope of at least 5 degrees, And well, here in the video, we can see that our robot is able to do it. And well, we can see that it is pretty easy. And well, we can say that we accomplished that part of the project.
Here we were testing the manual control of the AGV. This means that all of the movements that the AGV is executing are sent by the user via the phone application. After calibrating all of the left turns of the AGV, we went back to the complete track to see how it behaved there. So here in this test, what we were trying was to send a semi-autonomous command of L, F, and stop. This means that on the first red tag that the AGV reads, it should make a turn to the left, and then on the next red tag that it reads, it should keep going straight. After that, on the next red tag, it should stop, and that's the complete command that we send. After each red tag, it should go back to the line following until it reads again another red tag. On this video, we were testing the semi-autonomous drive, and through the application, we send the command right, right, and stop. This means that on the first red little tag, it should turn right and then go back to line following. And then when it reads again another red tag, it should go to the right again. And after the third red tag, then it should stop right there on the third red tag. On this video, we were just testing the left turns of the AGV, so we could see how it behaves on each of the left turn. So here we sent 6 left turns to see if it was able to execute 6 left turns one after the other one, and then after the 6th left turn it should stop right on the last red tag that it read.
As another requirement, the AGV has to behave as a line follower. And as we can see on the video, our robot is able to follow the line. And well, at the same time, it is able to detect obstacles and it will stop whenever an obstacle is in front of it.